Do the examples for Algebra 1A, Credit 2, Lesson 3.3. All right, in Lesson 3.3, we're going to be talking about evaluating a function given a domain. And when we say given a domain, they're just telling us these are the numbers they want us to substitute in for the variable, in this case, x. So let's go ahead and do that. First number we're going to substitute is 0. So we have f of 0 equals negative 3 times 0 minus 14. So wherever you see the x, you're going to substitute that number in. Negative 3 times 0 is 0, and 0 minus 14 is negative 14. So there is our first answer. Now let's take a look when x is 1. So now we'll substitute 1 in for x. And so let's box that to remind us that that's our first answer. And so we have negative 3 times 1 minus 14. So again, order of operations, just like we did on the first one, tells us we multiply first, then subtract. Negative 3 times 1 is negative 3. And negative 3 minus 14 is negative 17. Remember, when the signs are the same, you add the two numbers. 3 plus 14 is 17, and then keep the same sign. They're both negative, so negative 17. Finally, f of 2, we should be writing f of 0 and f of 1 here. F of 2, we have negative 3 times 2 minus 14. Negative 3 times 2 is negative 6. Minus 14, again, signs are the same, so we add them up. Make sure we can see that okay there. And we keep the same sign, so f of 2 equals negative 20. So now, those are the three answers. And what they're going to also ask you to do, it says in that problem, it'll say range, and then they have a little line there. And so they, just like we have the set of three numbers for our domain, we're just going to write our three answers, which represent our range. So that would be negative 14, negative 17, and negative 20. And so for number one, our example for number one, I should say, that would be our range. All right, very good. So now let's take a look at our example for number two. So number two, we have f of n equals n squared minus 5n. And our domain this time is 1, 3, and 5. So we'll start off by making some room there. We're going to start with 1. So f of 1 equals 1 squared minus 5 times 1. So all three places where we see an n, we're going to substitute that 1. Although we're not going to be doing anything over here, that just allows us, when we write the answer, to see the number that we substituted in for n. All right, order of operations, say we do our exponents first. So 1 squared is 1. Then we multiply. Negative 5 times 1 is negative 5. And then 1 minus 5 is negative 4. Because here we have a positive and a negative. So we subtract 5 and 1. 5 minus 1 is 4. The larger number is negative, so negative 4. All right, so our next number in the domain is 3. So we have f of 3 equals 3 squared minus 5 times 3. 3 squared, which of course means 3 times 3 is 9. And negative 5 times 3 is negative 15. Again, the signs are different, so we subtract the 15 and the 9, which is 6. And the larger number is negative, so negative 6. All right, finally, last number for the domain is 5. So we have 5 squared minus 5 times 5. And make sure we can see all that okay. Yeah. All right, so our exponent is first, 5 squared, which means 5 times 5 is 25. And then again, coincidentally, because 5 was part of the expression, we have another 5 times 5. But a negative times a positive is a negative. And 25 minus 25 is just 0. So 0 is our last number for the range. And so just like we did on the example for number 1, when we write the range, our three answers were negative 4, negative 6, and 0. And so we write those in our range like that, negative 4, negative 6, and 0. All right, so that is our example for number 2. Number 3 is now we're going to get into some word problems here. And just like we usually do, we're going to read the problem and then just change the numbers and work that example out. All right, so number 3, it says a miniature drone costs $300 plus $25 for each set of extra propellers. What is the cost of a drone and 4 extra sets of propellers? So in our example here for number 3, we're going to have a $400 drone, and the propellers are going to cost $50 for each set, and that's each set. And then we're going to purchase 6 extra sets. All right, so the first thing we're going to do is they want you to write the function. So we're going to say f of x, and let's do this so we can. So on the function line, what you're going to do is we'll say f of x equals, so we'll start with the cost of the drone, which is $400, plus $50. Well, if we were buying one set of propellers, it would just be $50, but for each set. So when we see those words like each or every or per, that tells us that we're that's where our variable is going to go, because it could be one set, it could be 3 sets. We don't know how many sets we're going to buy. Well, we do know it's 6, but this can be used to find the cost for any number of sets of propellers. So $50 or $400 for the drone plus $50 for each extra set of propellers. Now, the other thing they want us to do is find the total cost. So we know that we're buying 6 extra sets of propellers, so we're going to evaluate this function for the value of x, or when x is 6. So we're going to substitute 6 in for x. And again, even though it's tempting to want to add first because we do things left to right, we're going to multiply first because that's what the order of operations tells us to do. 50 times 6 is 300. And then we add 400 plus 300, and that's $700. So f of 6, meaning the cost for the drone and 6 extra sets of propellers, is $700. And when you have that answer, you put it on the cost line. All right, very good. So that is our example for number 3. Our example for number 4, it's very similar, but I think we'll still do an example just to see how this same type of situation or same type of work or function can apply to 2 different situations. So number 4 on the next page, page 32, the directions are to write a function in function notation and use the function to solve the problem. Number 4 says a cordless phone costs $55 plus $25 for each extra handset. What is the cost of a cordless phone and 3 extra handsets? All right, so our example for number 4, the phone is going to cost $75, and it's the handsets are going to be $45 each. So again, there's that word each, every, per, any of those words. That already kind of tells us where the variable goes. And we're going to buy 4 extra handsets. So first of all, writing our function, we'll start with our f of x. And we have, just like we put the cost of the drone first, we have $75 for the cost of the phone plus $45 for each extra handset. So $45 times the number of handsets we purchase, x representing how many handsets we're going to purchase. So that is our function. Now to determine the cost for the phone and 4 extra handsets, we're going to evaluate this function for the x value of 4. So we have 75 plus 45 times 4. Again, we do our multiplication first. 45 times 4 is 180. And we add that 180 to the 75, and that comes out to be $255. So the cost for a phone and 4 extra handsets would be $255. All right, now for problems 5 and 6, They want us to evaluate the function using function notation and then interpret the value or answer in context. So whenever it says interpret the value in context, in other words, we're demonstrating that we understand not only how to do the work and find an answer, but what that answer means. So it says in 2019, a science class is reading an article on global temperatures on the Earth Observatory page from NASA. A student determined the predicted global temperature in Celsius by the decade, is equal to the function f of d equals 0.20 d plus 14, where d is the number of decades. What is the value of f of d at f of 10? All right, so let's make sense out of that. So our example for number 5, we're going to evaluate this function. Now our function for our example is going to be 0.10d plus 12. And so we want to know the temperature in 8 decades. So we're going to substitute 10 in for d. And we have 0.10 times 8, which would be 0.80 or 0.8, either way, plus 12 gives us 12.8. So now we got the answer, but what does that mean? So that means in 8 decades, according to this example, the temperature, or global temperature, I think it says, will be 12.8 degrees. So again, interpreting the answer within context. So that's 5. And actually, this is number 6 down here, interpreting it in context. So 5 is solving it, where 6 is interpreting the answer in context. So on number 6, they actually write most of this out for you. You just have to take your answer from number 5 and write it in the blank. And finally, for 7 and 8, Joe wants to grow a habanero plant from a seed. He measured the height of the plant each day for 30 days. After measuring his plant for 30 days, he determined the height of the plant in centimeters is equal to the function f of t, where f of t equals 0.2 t, where t is the number of days that have passed since the seed was planted. What is the value of f of 30? All right, so in our example, we're going to do f of t equals 0.3 t, and we're going to find the value of f of 50. In other words, the height of the plant after 50 days. So we substitute 50 in for t, and then we only have one operation, just multiply 0.3 times 50, and that gives us 15. Now again, interpreting the answer in context, demonstrating that we know what that answer represents, and remember that it represents the height of the habanero plant. And let's just cross that there. So on the 50th day, remember we're evaluating this for f of 50. On the 50th day, the height of the habanero plant will be 15 centimeters. There we go. All right. So again, interpreting in context, that shows that we understand what that answer represents, not just how to calculate, not just how to multiply and get an answer, but what does that 15 represent? Well, it represents the height of the habanero plant in centimeters. So on the 50th day, the height of the habanero plant will be 15 centimeters. All right, that's it for the lesson 3.3. Good luck with the work. Remember, pause, rewind as needed. And we'll see you in the next video. Until then, take care and God bless.